Okay, so 2F says neither sports or a movie. So neither of them, right? So neither. So we say the probability of not sports, that's what the C means, right? Or not a movie, all right? So that's what that means there. So to do an or, we have to find the probability of not a sports first. So you go and count up all the ones that aren't sports. There are 102 of them. So 102 out of 120 because they're 120 total. Okay. And then over here you go up and then you add it up with all of the movie or all of the not movies because it's neither, right? So all of the not movies. So there are 95 of them that aren't movies. So anything else is okay. And then the last thing is there's some overlap. There's some that are in both. There are some that are in here and in here. So the overlap is not a sports program and also not a movie program. So you count up all of the ones that are not sports and also not movies. So everything else besides sports and movies. Okay. That's why I got that number. So then you add the first two, subtract 77, and you get 120 out of 120, which is one whole, right? Well, when you think about it, or means one or the other, right? So if it's not sports, that means everything besides sports here, right? Or not a movie. Well, isn't sports in here as well? Sports is in here, right? So movies are in here and sports are in here. So sports and everything, movies and everything else are in here because it's not sports. Sports and everything else is in here. So even though this says not sports, they're still counted in here, right? And even though this says not movies, they're still counted in here. So when I say neither sports or a movie, that's everything. That's everything. That's why it's everything. So that's why it's one whole. Like I said, a lot of times these questions, the way they're worded very. It's kind of hard sometimes to because a lot of times what happens is you try to do it all in your head. You try to do it all in your head, and you're like, oh, this is not that bad. What am I? And then this is where you make mistakes. So that's why stick to what we know. And since this is an or, we stick to our formula. Our formula will not lead us wrong. If we write the formula correctly, it will not lead us anywhere. It will lead us where we need to go, right? Because sometimes you try to do these in your head, and trust me, some of them you can do in your head, some of them that seem easy, once you do write them out with formula wise, they're not easy. Okay? They are not, they're a little more invested than you thought originally. Okay, so yesterday I told you guys about the formula sheet. So take a look at the formula sheet real quick before we go on to today's. So there's a front and there's a back. The back we use second semester. So the front is, let me see if I can pull mine up. Yep, here we go. So this is the front here. This is the front where it says formulas. Now, if you look at the left side, descriptive statistics, that's chapters 1, 2, and 3. Chapters 1, 2, and 3. We don't use any of these formulas because we use our calculator, right? The first one is how to find the mean. The second one is how to find standard deviation. This one here is a standard deviation we don't even use. This one here is how to find the regression line, how to find the regression line, or what is the regression line. Here is how to find the slope of the regression line. Here is how to find the y-intercept of the regression line. Here is how to find correlation coefficient, R. Here is how to find the slope, again, another way to find slope. And this is how to find the standard deviation of the residuals. We don't use any of those because to use them by hand is not productive, is inefficient. So the reason I haven't given you this is because we use the calculator to find all of these. We've use the calculator. So this side over here, don't even worry about. Don't even worry about this page right here. Where we start to use this is starting with chapter 5. Look at the first two under probability. The first one we've used already. That's the general, that's the general addition rule. The general addition rule is the first one we've used, and you will use quite a bit. The second one we'll use later this week. It's called the general multiplication rule. It's the general multiplication rule. We're not going to use that today, but later in the week we will use. Okay. And then the next 4 things we're going to use next chapter. These we're going to use next chapter. And then the rest of it, the rest of the first page, we're going to use in chapter 7. We'll use in chapter 7. Okay. That'll be where we finish the semester. Chapter 7 is where we'll finish the semester. And then when we come back, we got chapter 8, 9, 10, and 11, and just like a little bit of 12. And that's where the back will come in handy. Okay, that's where the back will come in. This is what you get when you walk in the test. So what can you use on the test? There's 2 things you can use, 3 things you can use. 2 of them they'll give you, 1 of them you have to provide yourself. The 2 things they give you are this paper. It's not going to be blue, but it'll be just a sheet of paper, right? They'll give you, I don't know if they'll be front and back, but it'll be this and your tables. They give you those to use. That's what they give you to use. And then the other thing you need to use is a calculator. Okay, a calculator. Those are the things you can use on the test.
What kind of calculator?
The graphic ones that we'll use. Yeah, the ones we've been using, yeah, for sure. Okay. So that's so like I said, I haven't given them to you guys before because we haven't really needed it, but now we're going to start to use it. Okay. Because these are the ones they give you on the test. All right. All ready? Okay, so let's look at the next one. The next one, the dorm room problem. The dorm room problem. All right. Okay, so the dorm room problem says a check of dorm rooms on a large, college campus revealed that 38% had refrigerators in their dorm rooms. 53% had TVs. 21% had both a TV and a refrigerator. Okay. What is the probability that a randomly selected dorm room has a TV or a refrigerator? Okay. So remember yesterday I told you there's 4 ways to solve these types of problems. 4 ways. The first way was Venn diagrams. The second way was two-way tables. Two-way tables. The third way was tree diagrams. And then the last way is using the formulas. Okay. Now, most of the time you'll use more than one. Like you'll use, formulas aren't very visual. Formulas are formulas, right? These guys right here. These formulas here, they're not very visual, right? You can plug them in, they're great, they work, but they're not very visual. The first 3, Venn, two-way, tree, are very visual. And trust me, it's a lot easier to see things when you can visualize them as opposed to just static formulas. Okay? So sometimes you'll use one and it won't work. So you'll use another. You're like, okay, maybe a table's better than this one. Maybe a Venn diagram's better for this one. Maybe a tree diagram's better for this one. Okay? So sometimes you'll use one and it won't work. They don't take very long to make, but trust me, they help. So this one I'm going to use a Venn diagram. I'm going to use a Venn diagram. The reason I use a Venn diagram is because they give me two options. They say refrigerators, and they say TVs, and then they say both. That's perfect for a Venn diagram because a Venn diagram has one side, another side, and the middle. Okay. So when we do Venn diagrams, when we start Venn diagrams, we always start with the inside, what they share in common. Okay. So we got a label first. So I'm going to say, I'm going to use R for fridge, R for refrigerator. So this circle will represent refrigerators. This circle will represent TVs. Okay. Oops. Okay, so we always, with Venn diagrams, anytime you're making a Venn diagram or reading a Venn diagram, start with the inside. So I'm going to start with the inside here, this part here. Okay, so what percent is going to go in there? 21%. Very good. 21%. So I'm going to put 0.21. I'm not going to put it as a percent. I'm going to put it as a decimal. You can use a percent, but I prefer using just decimals because they're most of the time you'll see decimals. Okay. Why did I put RV? Should just be R. Okay. All right. So, and then it says 38% had refrigerators. So what number is going to go in the fridge, the refrigerator circle? What number is going to go here?
0.38.
See, okay, so let's put 0.38 here. What percent of the people should be in the R circle? What percent did it say should be in the R circle? 38%, right? So how many are in the R circle? What percent is in the R circle? We went over, right? So yeah, the R circle includes everything. So that number up here, 38%, that's everything in the circle, right? So this number is not going to be 38. What is it going to be? 17, yeah, 0.17. Because that number, 38, represents everything in the circle, not just R. Because all it says is has refrigerators. Well, don't the 0.21, don't these guys have refrigerators? Right? And these guys have refrigerators, but they're in different groups. All right. Now the next one is TVs. 53% had TVs. Again, TV is in this circle here. So we need that to be 53% in that brown circle, tan circle. So what percent is going to go in here? 32. Right?
I mean, it is college.
Well, I guess if you are just eating like ramen noodles, you don't really need the
Ramen noodles, frozen pizza that you'll cook.
Yeah, it's tough. It's tough to live without a refrigerator. I would suggest having a refrigerator. Yes, because then you can't keep anything.
You don't need Mountain Dew at fridge temperature. Just drink Mountain Dew straight. Hot Mountain Dew.
Yeah, you guys will find out about that in plenty of time. Don't worry, you'll have those issues. Yeah. Okay. All right. So together they should add up to be what percent? 100%. So do they add up all three to be 100%? No. So what's the remaining? How much remaining do we have? Let's see. How much remaining do we have? 17 plus 21 plus 32. We have 70%. That adds up to 70%. Well, who are the other 30% then? People who don't have it either. So they're on the outside. They don't have a refrigerator nor do they have a TV in their dorm room. Okay. So what is the probability? So now we're going to find what is the probability that they have one or the other. So we need to find, this is asking what's the probability of a refrigerator or a TV. So we got, so be careful here though, because they said refrigerator, right? So we got to find the probability of a refrigerator plus the probability of a TV minus any overlap, right? Okay. So who has kind of running out of room here. Let me see. Let me do this. Minus the probability of R and TV. Okay, so who has a fridge? What percent, what decimal has fridge? 38%, right? All in the blue circle, and it says up there, so 0.38. Plus, who has TV? 53, all in the brown tan circle. Minus the both are in the middle. So what do we get? 0.7?
Yeah.
Okay.
I got the same answer, but I did it the wrong way.
Okay.
What?
Okay. Question B says, are the events has a TV and has a refrigerator mutually exclusive or disjoint? Disjoint means the same thing. So are they mutually exclusive? Well, what is mutually exclusive? We talked about this yesterday. What does that mean? What's that? Can't have both, yeah. So mutually exclusive means they don't have the same outcome. No outcome shared. So mutually exclusive means have seventh period PE, have seventh period English. You can't have both. There's no one that has both seventh period English and seventh period PE. Those are mutually exclusive events. Are having a refrigerator and having a TV, are those mutually exclusive events? No, they're not. I agree. They are not. How do we know? More importantly, how do we explain? Because 21% of students have both. A TV and refrigerator.
Nice to have.
Yeah, and that's another reason why the Venn diagram works, because you can easily tell. The number in the middle should be 0. If they're mutually exclusive, it means they don't share anything in common. It's either you're in one group or you're the other. You can't have both, right? Well, this one, no, because there's 21% have both. Okay, so that's mutually exclusive or disjoint. Sometimes they'll say disjoint. Most of the time you'll see mutually exclusive, but sometimes once in a while you will see disjoint. Okay, all right, so let me give you another problem. So we don't have any more problems on there, but we do. Let me put another problem up here. Where is my problem that I was going to find? Here we go. So if you have room on there, great. If you don't have room on there, find somewhere. Here we go. Okay. So A and B. It's got an A and a B.
That crash course.
All right. So let me put this one back up. Okay, so that is the
I still did the math wrong.
so what does it say? It says so in the middle 25% both, and then it says 28% use Instagram. So that means 3% are in just Instagram. And 68%, oops. That should be 3, yeah, thank you. Okay. And then that adds up to be, so this should be
29.
on the outside. Thank you. Okay. There you go. That's part A. Every option that exists, they call that a sample space because every option, either you have Facebook, you have Instagram, you have both, or you have none. Okay. So here, so my numbers are going to be off here, but this is essentially what we're looking for, right? We're looking for no Facebook, no Instagram. No Facebook, no Facebook, no Instagram. So my numbers are off because I messed up. Okay. So no Facebook. So I count up every green, or sorry, every red except the ones that are in the Facebook circle. So if you're in the Facebook circle, you don't get counted. So the ones in the Facebook circle are 68%. So everything other than 68% is 32%. Plus Instagram. So everyone outside of the Instagram circle. So everything outside the Instagram circle, inside the Instagram circle is 28%. So everything outside of the Instagram circle is 72. Yeah, thank you. Minus both, neither in Facebook and not in. So which one, how do I figure out? So I got to look at the ones not Facebook and not Instagram.
The outside. So 29.
So let's see. Anybody? 43 over here. 43. 43 is not Instagram, right? But is it Facebook? Yes. So it has to be both, right? It can't be one or the other. Either. So yeah, none of these are going to work because they're not both, for lack of a better verbiage. So the only ones that are not both are the out. Yeah, those up. What do you get? 75?
75.
So 75% are not Facebook or not Instagram. Not Facebook or not Instagram. Not both. That's not saying both. That's saying one, not one or not the other. So 75% of the people either only do one of them or they do none of them. Right? They don't use either social media. Okay. All right. Okay, so what I'm going to do now is that we're not going to go on. The next one is conditional probability, which will start tomorrow. But for today, I'm going to let you guys start on the assignment. The assignment's not in your textbook. It's on paper. Okay. So I'm going to let you guys, the last, what do we have? 25 minutes. I'm going to let you guys start on that. Yes.
We just give it to you. Or do we stuff it?
Nope. It's due regular homework. So if I sign it today, it's due, what's today? Tuesday, Thursday. But I want you guys to work on it. Don't put it away. We got plenty of time. Okay. I don't want to go on to the next one because we're going to need more than 25 minutes and I kind of don't want to stop in the middle.
35.
So I want to give you some time to work on the assignment. So I expect you guys to work on the assignment, okay? So in lieu of a book assignment, this is what it is, okay?